Hello everyone. Are you doing well? Or if I turn on my French accent, rebonjour. Ça va? Donc, more of AI things, but this one should be exceptional at some point. My talk today is going to be about shipping AI-powered React Native apps in the AI era, which is something expected, of course. So, before that, let me start by introducing myself. So, my name is Aziz Becha. I'm a 20 years old developer from Tunisia. And I think this is a good opportunity to celebrate my 6th year at GitHub and 100 followers, 100 people trusting my trash code somehow. Thank you. I mostly do open source things, and I'm here today to. My talk is going to be about shipping AI-powered React Native apps with three different ways. So everything starts with why. And today's question is, why integrate React Native? Why integrate AI in my React Native app? Anyone have an idea? Just because it's cool. so, uh, to integrate AI in React Native, we have more than a way, and there are the ways that allow us to empower our React Native apps with the AI. The first one and the classic one is the remote way. So you have an API and you request, you send a prompt and you get back the response. We have the on-device, and lastly we have the hybrid approach that you're going to see later. So starting with the first one, remote LLMs, it's very simple and it's the most classic way. For example, we can use AI from big providers such as OpenAI, Anthropic, Grok, etc., or even Chinese models. And this is simply how it works. First of all, we have a client. In our case, it's going to be the React Native app. And we're going to send an HTTP request to that endpoint that the company, such as, for example, OpenAI provides. We send the prompt, and we get a response back, okay? And to go deeper into that middle layer, it's going to be exactly like this in our case. So at the left, we have our React Native app, and it will not directly send the prompt to the LLM provider, because these providers require the API key for the authentication, and putting the API key in the client side, then it's gonna be included in the bundle, which is not secure. So we add this middleman here, which is the API route. So let's see a small demo together. So in our case here, we have a very simple project that is containing our React Native app alongside with our server. So here we have an Expo app, but exceptionally I'm running it on the web since I have two other simulators here that you're gonna see later. So at the end, it's the same thing. So here we have a small server that we built using TRPC, and we just simply here have some list of models that we can list, and from here we send a prompt, and when we send it, just let me show you the code, or let's say, what is React Native? It takes some time since I'm using some free providers, but this is the thing. By default, it generates Markdown, so you can use, for example, JSON UI, and you can make it more pretty. But this is the point. So this is the classic way of integrating AI in React Native. And if I need to go to the code chat, this is it. We just send that message that we entered in the text input to the server, like this. For example, yes, that's it. So we send that prompt to the AI provider by using OpenRouter that allows us to connect to many models flawlessly. And this is the classic way, so we discussed a lot. Okay, so let's get back to the presentation. Okay. And the question here, why use a central server? So to summarize all of this, as I said previously, it's not a good practice to include our API keys in the app itself, because when we export the project to APK or IPA, there is something called the JS bundle, and by default, our hard-coded API keys are included in that bundle, which can be extracted easily. So the best practice is to keep all the secrets in the server side. In addition to, for example, rate limitings, which is preventing people from spamming your server more than usual, and you can cache prompts to reduce the cost. And even that, we reduce the complexity on the app side. So let's keep it very simple. Like we have a server that handles all of these things, and our React Native app only shows the UI and these pretty things. The complex things, we keep them on the server side. So the pros of using remote LLMs is that they are faster than ever. By the way, they have a larger context, and they can stay with you for long conversations, and you don't have to host them or maintain them on your own. And you don't have to care about all that complex things. Okay, you just use the exposed API, and here you go. That's it. But on the other side, we have some cons. The first thing is the network dependency. So if your client doesn't have network access, so simply they cannot use that AI. In addition to the latency variability, it's also linked to the network dependency thing, and the more dangerous kind of thing, which is the third-party reliance. So there are some strict fields, like the medicine, for example. They don't allow giving their sensitive data to AI. So at this point, it's not a good thing to use remote LLMs. And finally, the black box behavior. So you don't know what is happening in the middle. You just send a prompt and receive the response back. But in most of the cases, this is good. Yeah, so we don't have any problem of that. Next thing, on-device LLMs. So using this approach, we kind of solve some of these cons. Okay. So the question that might turn into your head: is it logic to have a 7 billion parameters AI model running in your smartphone? This might seem crazy, but happily, yes, this is possible thanks to ReactNative AI by CallStack. So CallStack created a package called ReactNative AI that allows us to run local AI models directly in our React Native apps. And they made it easier than ever. And even the idea of this talk came after I contributed to that package. So this is the documentation in case someone wants to scan the documentation and take a look if they want. All good? Nice. So what is React Native AI? So simply, it's a list of packages that allows us to connect with AI providers such as Apple, which is strictly linked to iOS devices by design. And we also have, you can use Llama models, MLC, and also JSON UI for converting the output of the LLMs to a UI that we can draw. And Google is still work in progress, by the way. So in addition, we have a plugin for the AI SDK profiler DevTools, so we can monitor what is happening under the hood. And we can see, for example, such many parameters such as the given prompt, the received result, etc. You can find this in the documentation also. Starting with the first one, which is the Apple provider. And let me explain that. Nowadays, we are in 2026, we have iOS 26, and by design, even macOS 26 have something called Apple Intelligence, which are some AI models created by Apple. They are the same ones used in Siri. So we can make an advantage of using them directly for the users who have iPhone, for example. We can exploit that Apple Intelligence thing and run AI prompts for free without paying anything. Let's see a demo. ReactNative AI demo. This one, iOS. Pro Max. This case, I'm using iPhone 17 Pro Max. I have to relaunch everything because I cannot run two things at once. Okay, thank God. So this is the basic Expo app that you get when you initialize a new project. I just added simple tab and making it simple. Let's start by this. And here you go. Sorry, I forgot to add another proof. So I don't even need to have my Wi-Fi connected. I can even turn it off. But this is the point. And this feature, which is using Apple Intelligence models, is only specific to having iOS 26 iPhone, by the way. But somehow it helps reduce the costs. So this is the first way, and we have also the next provider for running on-device LLMs, which is Llama provider. So we're gonna see another demo in the other phone, Android phone. ReactNative AI is this one. So until get the build running, I ran it yesterday, and this is the given output. So I asked it the same question. I asked it, what is React Native, and it came back with this markdown things as always. Well, looks like this is crashing. I don't know why, for some reason, but this is the point generally. So here we have a list of open source models. By the way, this is the official demo provided by CallStack. They have a list of providers that you can use, but the problem is that you have to download them. And the model I downloaded yesterday, which is this small thing, it could took about 3 gigabytes, I think, and it's heavy, so you better download it. It takes some time. It kind of takes some time to download. So okay, see the next thing. So let's go again to the pros and cons thing. The pros of using on-device LLMs first is the privacy. So the data you give and receive from that LLM is private and only lives in your device, and it supports offline status. In addition, you don't have to pay anything, not like the remote LLMs. But the consequences are much more than that. So you have to you wait for the model to be downloaded, and they are not lightweight. They take even 3 gigabytes. It's a normal thing. And in addition of that, they are somehow limited. And if you discuss with it, like give it 10 more prompts, the context is gonna be filled up, and you have to reset the entire conversation. And finally, it needs some heavy dependencies. Like when I tried to run it on a 2 GB from Android simulator, it crashed from the first prompt. And everything here is a kind of trade-off. So when you use the remote, you have a pros and cons, and when you use the on-device LLMs, you have also pros and cons. So going quickly through that. For the privacy, you are totally private when you are using the on-device LLMs, but on the other side, you are not. Your data is not yours when you use remote ones. For the network, it's required for using remote LLMs, but it's not required for the on-device. For the cost, when using remote LLMs, you pay per token, but locally you pay 0, etc. And to summarize this, the remote LLMs are much faster and more up-to-date, but the on-device are from average to good. You cannot rely 100% of them, but they do the job. So the recommended solution here, since the on-device approach has a lot of pros and cons, and also the remote has also its own pros and cons, we're gonna recommend the hybrid approach, which is exactly like this. So we can make our app depend on both at the same time. For example, when someone downloads the app, we start downloading the local model on the background and save it for the time we need it. But mainly we use the remote and use the local as a fallback if there are some network issues, for example, or if we have some easy prompts that doesn't require us to pay for another service to get the result. And I have a bonus, which is the optimization tricks. Since the providers charge us per token, and the more your prompt and the input/output is big, the more you're gonna pay. And that's why I'm gonna mention TONE, which stands for Token-Oriented Object Notation. It's simply a tool that converts, for example, this format of JSON that most of you know, it converts it to this compact type, so it uses less tokens. Let's see a demo together. Okay, this is the background. I don't know if I have, yes, happily they have icon. So here we have a somehow heavy JSON schema, and using Tune, we reduced it to be like we cut more than half of the size. Same for the cost. So Tune is very helpful on this point. They have a CLI. It's open source on GitHub. They have you can use it using the CLI, or they have an SDK for TypeScript by design, and they have also other providers. There are some small benchmarks to show how it cuts off the cost generally. So closing this talk with this tweet that I found, and I love it very much, by Naval, someone I highly recommend. I liked it, so I wanted to add it to my talk. So there are any questions?
Eh ben, merci beaucoup tout le monde.